Hey everybody, this is a little video to help you figure out resistor color codes. Over here I have a resistor. Now these resistors represent the ceramic resistors that we see a lot of times in electronics. And they use colored bands to help identify their resistive value. In this case, I've given us an example. It's got a red band, a blue band, orange, and gold. So what exactly does that mean? We have to use each band as a value, and keep in mind that the gold, silver, or no color, that's the last band. So we start reading the bands from as far away as you can from the gold, the opposite end of that resistor. We also use a little jingle to help us remember the colors when we're building the table, because every table, every color has a different value in the table. So Bill Brown races our young guys, but Victor Gray wins. And then we have gold, silver, no color as our tolerance. So what does that mean? Well, the colors are black, brown, red, orange, yellow, green, blue, violet, gray, and white. And then each band, we have to determine something special from it. So the first band, all we're going to do is take a number. So in the first band, we know that numbers can be 0. So our black is going to actually be a 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't go into double digits here. You know you've done that incorrectly. Now the second band is also going to be a number. So it's going to actually run the same way, starting at 0 all the way up to 9. The third band is actually a multiplier. Now we can't multiply by a 0 or it would end up being no value at all. So this third band is basically times 1, times 10, times 100, times 1,000, times 10,000, times 100,000, times 1,000,000. Large numbers here, 10 million, 100 million, and okay. Now that's our multiplier, the third band, and our fourth band is actually the tolerance. So this is where the gold, silver, and no color come into play. And what that means is how much does this resistor actually vary from the colors that from the value that we calculate from the colors. In other words, is it really close, as in 5% plus or minus 5% of what we thought it was, or is it quite a bit different, maybe perhaps as much as 20% different than we calculate? One other thing is we can have a multiplier of a small number, and so when I look at the multipliers and I look at gold and silver, we could actually go into decimal values, 0.1 and 0.01. So instead of multiplying by a whole number, we'd be multiplying by a decimal. So let's explore this a little bit and see what this red, blue, orange, gold resistor would actually be. So we said the first band was a number. So I'm going to look at the first band. It's a red. I take my red from the first column here, and so we're going to be counting a 2 for that. Then I look, my second band was a blue, so I have to go down to blue, and from the second column I see that it is a 6. Now my third color is an orange. That's our multiplier. I have to multiply this number by 1,000. So I'll end up with 26,000 ohms of resistance. But we said that some resistors are made better than others, and that's going to show up in our tolerance. And in this case, my last band was a gold, which says that this guy is actually pretty close to what I thought it was. So it's going to be 26,000 ohms plus or minus 5% of that 26,000. Thanks a lot. I hope that was helpful.